The question I get asked the most is, my code doesn't work. I've got this cryptic error message and I don't know what to do. Please fix my code for me and make the error go away. Well, today I'm going to show you how you can fix your code yourself. I will walk you through the process that I go through whenever I get an error message. I will start with an easy one and then we'll take a look at a very difficult one.
Here we are in Spyder, and I'm going to create a fantastic data analysis script. Yes, ladies and gentlemen, we are analyzing some MAG data today. And not just any MAG data, but the very best MAG data. By which I mean, of course, the MNePython sample dataset. These lines of beautiful Python code will read in the continuous data and show it to us. And we're done. Let's run it by pressing F5. Oh no! It's not working! Let's try it again. It's still not working! What is this? Oh no! Calm down. Don't panic. Read the error message. A Python error message begins with the traceback. The traceback tells you exactly what the computer was trying to do when the problem occurred. It goes like this. I was trying to execute this line of your script. It calls the read roll fifth function, which was all running fine until it tried to create a roll object. Creating the roll object worked fine until it tried to call the read roll file function. And this function was doing just fine until it tried to call the fifth open function, which in turn called fifth getFID, which used Python's open function to actually open the file, and this is where all hell broke loose. And finally, it tells us what the actual error message was. See, the open function failed with the following error message. File not found error. Error number 2. No such file or directory. And then this file path. This looks like the file I was trying to open. So why did it fail? It says it couldn't find the file. Computers are annoyingly accurate in finding files.
If an item does not appear in our records, it does not exist.
Python claims that this exact file path does not exist. Two options. 1. Either the file does exist, but for some weird reason the computer cannot find it. Or 2, and this is infinitely more likely, the file path is wrong, even though it looks correct to me. I find Jupyter's lsmagic command useful for checking file paths. I've copy-pasted the file path, so I'm sure to carry over any mistakes. Backslashes have special meaning in Python, and in the error message they were escaped with another backslash. I have to get rid of those. It seems that the file path is indeed wrong, which means I was wrong, and admitting this is the first step towards recovery. Let's see if I at least got the folder right. Yes, the folder does exist, but the file I wanted to open is not inside it. The only thing in it is another folder called sample. And it is within this folder where we find the file I wanted. Now I can fix the code. And run it again. It works! Just look at that wonderful MAG data.
Yes!
The data was recorded with a Magin vector view scanner. This type of scanner has 3 different sensor types: magnetometers, gradiometers and EEG electrodes. Let's print for each of the 306 data channels the type of sensor that is attached to it. F5, run it. Oh no, everything is broken again. Okay, don't panic. What did we learn from last time? Read the error message. It was at the bottom of the traceback. Value error. Pix CHS could not be interpreted as channel names, no channel CHS, channel types, no type CHH, or a generic type, just all or data. Well, that doesn't make any sense at all. What is this CHS thing? I'm afraid, ladies and gentlemen, that the error message is of no sudden use here. In cases like these, you will have to get your hands dirty. We're going to have to jump into the MNE-Python source code to see exactly what went wrong. I'm now going to use the most powerful Jupyter magic command of them all. Debug. The debug command drops you into the post-mortem Python debugger. It allows us to explore the state the program was in when it crashed. Here we are at ground zero, the point where disaster struck. Deep in the bowels of MNE-Python, a value error was raised. The question is why? I see that the error was raised because allow empty was false, and the sum of any found equaled 0. But none of these seem related to what I wanted to do, which was to print out the sensor type. Let's go up the call stack to the function that was calling this function. We do this by typing up. This part of the code is obviously a mine of some sort, pigs everywhere. Let's go up further still. Still deep in the woods. Up we go again. Now we seem to be in the getItem function of MNE-Python's raw object. How did we get here? Well, nothing I can do except going up again until I'm back on familiar terrain. Here we are. The channel type function. This is the function I called from the script. And this is the line that failed. Let's execute it manually by copying it into the console. Yeah, that fails alright. At least I now know where the CHS comes from in the error message. Okay, what does this info variable contain? It contains a raw object. And indexing a raw object with the string CHS obviously doesn't work. Where does this info variable come from? This line is the very first line of the function. The info variable comes from the first parameter given to the function. Since I was the one who called the function from the script, the info variable is the first thing I passed into the function. I probably gave the function the wrong thing. Let's read the documentation. Oh yeah, the first parameter needs to be an instance of info, and I passed it an instance of raw. It's days like these that I really wish that MNE-Python used type annotations. Let's exit the debugger and get back to the script. Instead of giving the channel type function the raw object itself, I need to give it the info attribute of the raw object. There. Let's run it.
It works! And that's how you fix an error message.